Hello, today I will show us how to draw free body diagrams. Now, a free body diagram is used to show the relative magnitude and direction of all forces acting upon an object in a given situation. To draw a body diagram, we represent the object in that situation by a box. And next, we draw the forces acting on this object from the center of the box outward in the direction that the forces are acting. Now, for our object, we have at least 4 forces that can affect this body. The first one is called the normal force. This force is the force that acts on the surface. So, normal force always acts upwards. The next force is the gravitational force, or we can say is the weight acting on the object. It always acts downwards. This is the force that pulls the object down. We have the applied force. This is a force that is applied on the object. It can be either due to a pull or a push. Then also we have the frictional force, which is the force that opposes motion. So these are 4 or some of the forces that can act on an object. Next, I will show us some examples of different situations and how we can construct the free body diagram. Now, we are asked to construct free body diagram for this situation. A book is at rest on a tabletop. The first thing I do is to draw a box for this book. The next thing I do is to identify the forces acting on this book. Now, the book is at rest, so there is no applied force. And the book is on a tabletop, so there is a normal force acting on the book. A normal force, because the book is on a tabletop. And also there must be gravitational force acting on it. So for this question, there is no applied force because the book is at rest, and also there is no frictional force. For the next question, it says a rightward force is applied to a book in order to move it across a desk with a rightward acceleration. So first thing, I draw my box. Alright, now the book is being moved by a rightward force, so we have an applied force moving the book to the right. Also, the book is on a desk, so there is a normal force acting on the book. We are asked to consider frictional force, so there is a frictional force. Now, there is a force of gravity acting on this book. So this is the free body diagram for this situation. Also, we have a next question. It says a college student rests a backpack upon his shoulder. The pack is suspended motionless by one strap from one shoulder. The first thing I do again is to draw the box. The next thing I do is to draw the forces. As you can see, there must be a gravitational force acting on this object. Also, it says the back is at rest, so there is no applied force and there will be no frictional force. But we are told that the pack is suspended by one strap, so there is a normal force acting on the backpack. This is the normal force. So in this case, there is no applied force and there is no frictional force because the book is at rest. So this is the free body diagram for this situation. Also, we have a next question. It reads, a car is coasting to the right and slowing down. We are asked to neglect air resistance. The first thing I do again is to draw my box. Now, what are the forces acting on this object? It says the car is coasting to the right and slowing down. Now, because the car is applying brake at this point and slowing down, there will be a frictional force acting on that car, and the applied force will be very what? Minimum, because the car is coming to a rest, so I can ignore the applied force. Now there will be a force of gravity acting on this object, and also because the car is on the road, there will be a normal force. So this is the free body diagram for this question. Now I'll show us one more question. It says a free body diagram. Construct a free body diagram for a football is moving upwards towards its peak after having been booted by the punter. Neglect air resistance. The first thing I do again is to draw my box. Now, if you look at the question, the ball is pushed or is moving upwards and towards its peak. Now, this ball, despite it being moved upwards, the ball will or does not remain up. The ball drops, so there is a force of gravity acting on that ball. Now, in this case, there will be no frictional force, there will be no applied force, there will be no normal force. There will be no normal force because there was no force strong enough to keep the ball at its peak. When the ball got to the peak, the ball drops. So the normal force at this point or at the peak is very small and not strong enough. So we can ignore or neglect the normal force. Alright? In this case, there is no applied force and there is no frictional force, because frictional force occurs when there is a surface. In this case, the football is in the air, so there is no surface for us to have friction. So there is no frictional force and there is no applied force. So the only force acting on the ball is the force of gravity.